Alright, so do a couple quick examples of solving mass-to-mass calculations. This would be the example, starting with the example on page 310 in your book. We'll do the sample problem E and then practice problem number 1. And if you can do those, then you can do, if it's moles to grams or moles to moles or grams to moles, any of those combinations, if this is the longest possible variation. So it says in tin 2 fluoride, which tin 2 should I spell it fluoride. So that means tin with a +2 charge, fluorine's a -1, so SnF2 used in toothpaste is made by the reaction of tin with hydrogen fluoride. So we have tin plus hydrogen fluoride yields tin 2 fluoride plus hydrogen gas. So the question is how many grams of SnF2? So grams SnF2 is what I'm looking for. How many grams of SnF2 are produced if I start with 30 grams of hydrogen fluoride reacting with tin? Alright, so we're just going to move this over here. So Sn plus HF yields SnF2 plus H2. Okay? Oops. I have to balance it, obviously. Remember, always balance your equations. So I put a 2 here, and that is balanced. So, starting with 30 grams of hydrogen fluoride, right, grams HF, starting point. Now, I'm going to convert that into moles hydrogen fluoride first. That's got to be my first step. Remember, I've got grams right here, which means grams has to go here. It's going to force me to set it up in the right way. And then figure out, well, what is HF? Okay, well, H, that's 1.01, and F is number 9 on the periodic table, 18.998, which rounds to 19.0, and there's only one of each of those. So 20.01 grams per every mole. So that goes here, 20.01. So now I have a division problem. That's going to give me moles of HF. And then we're going to go, well, I got moles of HF in the top, so that means moles of HF has to go in the bottom. And now I can use a ratio. I'm going to go moles of SnF2. Okay. And then fill in my numbers of my ratio. Here, there's a 1, an understood 1. And HF has a 2 in front of it, so a 1 to 2 ratio. And then I would multiply that by the molar mass of SnF2. So tin, which is number 50, 118.71. And there's only one of those. F, 19 times 2, so that's 38. And 118.71, 7165, 156.71. Okay. 1 mole SnF2, so that way moles would cancel, and 156.71 grams SnF2. Now before we do the math, we'll check and see that our units all cancel. That'll tell us that we set it up right, so I've got grams of HF in the top and a gram of HF in the bottom. Alright, I've got moles of HF in the top, moles of HF in the bottom, so those cancel. I have moles of SnF2 and moles of SnF2, and the only thing left that I didn't cancel, the only unit left over was grams of tin fluoride. So that would have to be, it would indicate that this is set up correctly. So provided my numbers are correct and I do the math right, it should be the right answer. And all of that, so 30 divided by 20.01 divided by 2, and that answer times 156.71 equals 117.5 grams SnF2. And that would be your answer. Alright, so let's do the next one. Laughing gas, N2O, is sometimes used as an anesthetic, produced when ammonium nitrate is decomposed. So I have the decomposition of ammonia, which is NH4, nitrate, NO3. Those are both, it's +1 and a -1, so it's just that. Decomposes into nitrous oxide and water. And that is balanced. So how many grams of ammonia nitrate are required to produce 33.0 grams of N2O? So I'm looking for grams of NH4NO3. That's my big unknown here. All right, so that's what I'm looking for. So, but I'm starting here with 33 grams of this stuff. So that's got to be my starting point, right? So I write my start, 33.0 grams, N2O. That's my starting point. That goes over 1. All right, always have to go into moles. 1 mole of N2O ratio to the molar mass. So we're going to go say N, which is 14.01 times 2, and O, which is 16 times 1, so 16 and 28.02, giving me 44.02 grams per mole. All right, that number's the number that goes up here. Grams, N2O, so my units look like they're going to cancel. Now, we will string it on, but this is a two-part question, so we're actually going to stop right here just for a second. And instead of doing the math all at once, we're going to get the molar amount of N2O, so that in case we need to go further, we can use it. So 33 divided by 44.02 gives me 0.749659, so 966 moles of N2O. Okay, so we'll save that value. Now I'm going to continue. I need to go from moles of N2O. I'm going to ratio that to my unknown. Now that I have it in moles, so I'm going to ratio N2O to NH4NO3. All right, so we had 0.74966 moles N2O. All right, well, based on my balanced equation, it's a 1-to-1 ratio. 1 mole NH4NO3, 1 mole N2O equals 0.74966 moles ammonium nitrate. All right. But the question was how many grams, okay? So I need to go from moles to grams. So I have 0.74966 moles NH4NO3. And I got to figure out the molar mass of that. Well, N times 2 and H times 4 and O times 3 gives me a grand total of 80.06 grams of NH4NO3 for every 1 mole NH4NO3. And the units do appropriately cancel. And when I do that math, I get a grand total with 3 significant figures of 60.0 grams of ammonium nitrate would be required to start the decomposition. Now the second part then says how many grams of water are produced. Well, to do that we have to go back to one of our knowns and figure out a mole ratio. Well, conveniently we wrote down the number of moles here of N2O that we started with so we could refer back to it later. So all we have to do is set up the ratio of that, so 0.74966 moles N2O, ratio that to moles of water. And based on our balanced equation, it was a 1 to 2 ratio in this case. So 2 moles H2O for every 1 mole of N2O. So I take 0.74966 times 2, and then that's going to give me, and I'm going to say 1 mole H2O is 18.02 grams of H2O. So I'm going to multiply 7.74996 times 2, and then multiply that by 18.02. I'm going to get an answer of 27.0, 3 significant figures, grams of H2O. So as you're going through, feel free to do all of your work in one big step like that. That's fine. However, generally when you get right about here, I would stop, look at your calculator, write down the molar mass or the molar amount that you got like we did here, and then keep going. That way, because you're generally going to have to refer back to it later. So might as well save it so you only have to do all the work once. All right, so that is how to solve a mole-to-mole stoichiometry problem. And if you can handle this, you can handle any of them, because if your answer, so here our answer started in grams, and we converted it to moles, and then we did a ratio. If your answer already starts in moles, then you just don't have to do the conversion. You get to save one step.